Alright, hi, welcome to Adam's little lesson in Charter Conductor Mailroom. Alright, which this is your Delta Sysmal three-way winding. Basically, it's just like an amperage pedal. You can adjust the amps, ohms, voltage, watts, hertz, going from input and output. And then moving on, if you have an AC, what it has to do is it has to go through a rectifier bridge. These are diodes. So what it does is it changes AC into a DC. Half of them are AC, half of them are DC. Splits it up in the half circle. All right, these are plate screen stacked, usually in transistor oscillators. You'd have a positive, negative, positive plate screen or plate with a negative, positive, positive plug. The collector, emitter, drain source goes through that and collects the different ways. Alright, this right here is your engine coil pack. One would be your first distributor engine cylinder 1, 2, 3, 4, 5, 6. In a matrix symbol over here, this is one I got off the internet. It's not exactly the same as this, but it goes 1, 2, 3, 4, 5, 6, 7. So basically that's a matrix, okay? Your coil pack and what it uses to fire the engine. Usually the crankshaft has some different, whether it be 4-stroke or 2 or so many stroke are in line, how the pistons are in line. Next over here we have a 9-digit, a 3x3 matrix on the top. This is how you do matrix algebra, and this would equal these equivalents. 3x3 matrix used for 9-digit pads, zeros, and anything times by 0 is not used. And then you have your 2x3 matrix algebra over here, which is used in 6-cylinder engine coil packs. This would be if your 9-digit was positive, like consider the flow from this right here going through the path in a positive, negative type way. Here's some example of a 9-digit. This one has amplifiers, 50 ohm resistors, pins. And this would be lighting diodes, so your lights would come up on your 9-digit screen, or certain resistors. These would have adjustable variable resistors, which could actually do algebra because you're adjusting the variable and the resistor. This one has capacitations and breaks and voltages, biases. This would be this is your up here is the voltage source going through a resistor capacitor. There is a tuned RL circuit. The R resistor and capacitor regulate the proper voltage across the induction. Just like in tuning a radio, there's a set voltage through a spec, whatever electronics over the power supply or operating voltage. You have either it's fixed, it means it's or it's polar, or it's a variable, which means like it can change. Notice the variable over here. We're going to talk about that when I show you my deck of cards. Okay, so you'd have a variable resistor. These are your capacitor symbols. Resistors, same thing. Fixed resistor, a variable resistor. Variable potentiometer resistor means you can measure the amount of resistance, and then your variable resistor across. And these over here in inductions, I really don't get into induction, but same. Basically, your capacitor, fixed, polarizer, variable. This is a high-powered siren. Notice that these resistor 1 and resistor 2 capacitate the base and the source of transistor 2, resistor 1, transistor 2, resistor 4, 3, 5, 6. You have to have a resistor capacitor to tune a circuit, so we'd have your ground over here, capacitor 4, tuning the circuits of resistor 1, 2, 3, 4. There's 8 resistors, 4 different battery switch and whatnot. Alright, that concludes with the the slideshow part of it, and I'm going to show you some of my drawings.